Introduction to limits. What are limits? What I have here is a simple function, f of x equals x plus 2. And notice when I put in x for 3 right here, 3 plus 2 equals 5. So my equation ends up being this coordinate right here, 3, 5. And that's where I got the little blue dot pointing at. Same thing, if I start at 5, x plus 2, 5 plus 2 will equal 7. So x plus 2, f of x, equals x plus 2, and my x is 5. My f of x, my y, will be 7, which is what I have right there. 5 comma 7. Simple equation. Now, what we say here, because it's moving, this line is moving. It's a positive slope. It's going up and to the right. We've already talked about slopes. And for this reason, there's a limit at f of f at x equals 3 is 5. As x is 3, f of x is 5. Now, what is the difference between the limit of f at x equals 3 and the value of x equals 3? Now, what I have here is called a hole. You remember this when you're doing number lines. If you had a number line like this, and you had, let's say, 0, 1, 2, 3, and you want to say the entire set from 0 to 3, but it can never be 0 to 3. You can get real close to it. That is called a hole there. It could be 0.000001, and this could be over here, and this could be 2.9999. It can never be 3. You can get close to 3, infinitely close to 3, infinitely close to 0. It's the same thing here. I am approaching 3. It could be 2.999 right here. It could be 3.1111 right here. And that would give me really close to 5, like 4.9 and 5.1. But can never be actually be 3. And if it can never be at 3, it can never be at 5. So we're getting very close to 3, but not 3. And notice I have an arrow going from below it, right here, and above it. When my equation might be f of x equals x plus 3, but where x is 3, it's undefined. It does not exist at 3. So, however, the line shows as we approach 3, both from the left, from 2 to 2.5 to 3, and then from the right as it goes down to 5, 4, 3, we get closer and closer to that 3. And it's existing as we're approaching 3 like it is 3. Can't be 3, but it's approaching it from both ends. And that's what we call a limit. The limit is 3. It's approaching 3. Now here I've got q of x when x equals 3. Here's a different equation. It's actually part of a sine wave. Right there, it's approaching x equals 3. Now, what's the reasonable limit for q of x when x equals 3? As it approaches 3, it's going to approaching -2. It doesn't equal -2, it's approaching -2. And we write this notation like this. LIM is limit. This is the function. And this is as it's approaching that. x approaching 3, limit of f of x. And our early equation is approaching 3. We said limit of f of x would equal 5. The limit, it doesn't mean it will be 5. It's approaching 5. Now, there's some rules. We're going to learn a little bit about this. But look at this. Now, here is what I have. We're going to learn about discontinuities in another session here. What is a reasonable limit as x approaches 3, h of x? Remember, here's my x on the x-axis. Here's my h of x. There's only y-axis. And as x approaches 3 right here, this is interesting here, because what this says here, this is close, it's approaching 4. Now, it doesn't exist at 4, but it's approaching 4. From this side, that's my h of x, and from this side. Now, what's interesting about this is I got this dot here. As x is at 3, it equals -5. This is removable from there. But as it's approaching it closer and closer and closer, it is approaching -4. So don't get fooled by what it actually is. It's on where it approaches from both ends. Here's one right here. What's the expression? Limit of x squared as x approaches 5. Well, here is 5, because this is 10, 15, 20. It's group of increments of 5. And as x approaches 5, my x squared, 5 and 5 is 25. Not only does it equal 25, because it's a solid dot here, it's approaching it from both ends. From below and above it, from the left and to the right. So this is the answer. Limit as x squared approaches 5 equals 25. But we would write this as down here is always the x component, not the x squared, not what the x goes to the y, either one of these. It's not the limit of 5 squared. We write this as the x below it and in the equation right here, where it's approaching. Now it's infinitely close. When we had that graph, a log of fx equals x plus 2, and we said it can get very close to 3. It may not be able to be 3 itself. In fact, I had something like this. And looked at a hole right here. It couldn't exist at 3. And this was my 3. And this was my 5. But if it was 2.999, the f of x would be 4.999, as I got right here. 2.999 would be 4.999. It actually works at both ends. It's approaching 3. It's getting infinitely closer to 3. And my resulting answer is infinitely closer to 5, but it never will be 3. And the same thing as this, as x approaches 3 on the other end, be 5.1. 3.01 gives me 5.01. 3.001 gives 5.001. Getting close from both ends. We'll never get to 3, but we can get infinitely close to 3. This is the table right here. What's a reasonable limit of x approaching -7 of f of x? Well, here's 7.01. This is getting closer to -7. This is even closer. And from this end, 6.9, 6.99, -6.999. And I would say this goes 6.32 at both ends. 6.1, 6.03. A reasonable number would be right between that, probably 6. And that's why I picked that one right there. What's the limit of x squared as x approaches 2? Well, 2 goes, it's approaching 4. Here's 2, and this is actually right there, and x approaching 4. And I could put 1.9 for x. 1.9 squared is 3.61. 1.99 is 3.9601. 1.999 is 3.99601. And I did it from approaching from the right as well. 2.1 is 4.41, 2.01 is 4.04, 2.001 is 4.004. Notice in both cases, we are approaching 4 from both the left, from this side, and from the right, from this side. And they're both approaching 4 from different directions, but they're both approaching 4. Now, for a limit to exist, you have to approach the same thing from both sides. I'm approaching from the left. This is the left side right here. I'm approaching as x approaches, as the limit of x equals 3 approaches 3 becomes 5. And x approaches from the right, it's also approaching it right here. Now, this is not a limit. My x from the left here, where this arrow is when it's at 3 from the left, even though there's a hole here, it's approaching, it looks like 4. And then as x approaches from the right at 3, it is 6. So guess what? This is not a limit. It's both got to be approaching the same number. 6 is not equal to 4. So this does not work. This is not a limit. Now I want to go through this. Let's determine which limits exist on the graph of the function f of x. Let's see here. And I'll go through each one of them. X approaching 1. X approaching 1, well, that it would be 2. Yeah, and it's approaching 2 from both ends. So this is, let me erase that there. It's a nice straight line. I don't know how I did that. This is a limit. As x approaches 2, y equals 4. Yep, it's approaching. It's a little bent here, but it's both approaching 4 from both ends. So that's a limit. X at 3. Here's 3 right here. Nope. This is as x approaches 3 from the left, this is 9. And as x approaches 3 from the right, this is 15. So that is not a limit. A check mark there and put no. As x approaches 12, x approaches 5. X approaches 5, I got a hole right here, but we're still approaching 12 from both sides. It may not be able to equal to 12, but it's approaching 12. So this is a limit. As x approaches 7, yes, there's a bend right here. But what we're going to learn later is this is not a limit because we can't do sharp turns. Why it is both approaching 7, we can't do sharp turn. I'm going to teach that 2 sessions from now. So this is not a limit, and I'll explain that in more detail. X equals 8. This is interesting. This is a limit. As x approaches 8, from the left, it approaches 15. From the right, it approaches 15. There's a hole. Well, we're approaching it. I didn't say when x equals 8. When x equals 8, I get this. But as approaches 8, equals 15. So that is a limit. And x equals 9. Well, guess what? I got something right here, but it's only one side. There's nothing on the other side here. So it is not a limit. It's got to approach from both sides. So this does not exist.